Okay, today we'll be taking a look at a question on differential equation. So this question says the variables of x and y are related by this expression. Just write it down on the board first. So pi dy dx plus y bracket 3 minus pi tangent x equal to 0. So the first part of the question, you are supposed to use the substitution of y equal to z secant x to show that dz over dx equal to minus 3z over pi. So the substitution is y equal to z secant x. All right, so take note when we are given an expression for the substitution like this, we are not supposed to treat this like a constant. All right, if it's a constant, they will specifically say so. So in this case, we are supposed to treat it like a variable. So our objective for this question is to replace all the y away. So this part here, I want to replace away. This y, we also want to replace away. So what we can do first is to first differentiate respect to x to get a dy dx term. So hopefully we can replace away here. So we get dy dx will just be equal to, now we got to make use of product differentiation. So I keep c, differentiate secant x, so we get secant x tangent x. This differentiation can be obtained from the formula list. Now I would like to keep this and differentiate this. I'll get secant x dz over dx. Right, so now we can do a bit of replacement for the y's away. So I'll get pi. So dy dx I will replace with this entire expression. So I got z secant x tangent x plus secant x dz over dx plus, and y can be replaced with this z secant x 3 minus pi tangent x equal to 0. All right, let's see how we can simplify this. Okay, I can observe there are common terms here, secant x, secant x, secant x. So we can do a bit of cancellations. And maybe I'll just multiply in the pi and multiply the z in here. So I will get pi z tangent x plus pi dz over dx plus 3z minus pi z tangent x equal to 0. All right, that's very good because I see there are common terms here, this and this, so it can be cancelled away. I will just simply left with pi dz over dx plus 3z equal to 0. All right, bringing this over to the other side and dividing by pi, I'll get dz over dx equal to minus 3z over pi. All right. Oh, that's good because this is the first part I need to show. All right. So now the next part, the question says you're supposed to show that the particular solution for which y equal to 2 when x equal to pi over 3 can be expressed into this particular equation here. So my guess is we got to solve this equation here. And we can recognize that this is of the form of a variable separable because I should be able to group all the z on the left hand side and group all the constant and x if there's any on the right hand side. Just rewrite this properly, so dz. Right, so what I'm going to do is to shift the z to the left hand side. So I will get 1 over z dz over dx equal to minus 3 over pi. Right, then we will integrate respect to x on both sides of the equation. I will left with integrate 1 over z dz equal to minus 3 over pi, integrate 1 dx. All right, now doing integration, I'll get ln mod z equal to minus 3 over pi x plus c. All right, now I will try to make z the subject. Let me just erase this to make some space. All right, so here I will get mod z equal to e to the power of minus 3 over pi x plus c. Removing the modulus, I will get plus minus e minus 3 over pi x. And this, I can just split up the exponential. I get e to the power of c. All right, maybe I just rewrite it one more step here. I will get e to the power of c times e to the power of minus 3 over pi x. And this plus minus e to the power of c is basically just another constant. So I can just replace this entire thing with another a. So I will get z equal to a e minus 3 over pi x, where a equal to plus minus e to the power c. All right, now we are also given the initial condition whereby the question says when y equal to 2, x will be equal to pi over 3. Right, with these values, I can just sub inside. But before that, I will just replace my z back with my y first. From here, we can see that z is the same as y over secant x. So I can do a replacement. So I'll get y over secant x equal to a e to the power minus 3 over pi x. And this we know that actually is the same as 1 over cosine. So I will just simplify a bit more. I get y cosine x equal to a e to the power minus 3 over pi x. Right, now we can sub in the values they have given us. So by subbing in, let me just write it here. I'll get 2 cosine pi over 3 equal to a e to the power of minus 3 over pi x will just be pi over 3. Right, doing a bit of simplification, I will get 2, this is half, a, e, this one will just left with power minus 1, and a will just be equal to e. So therefore, my final general particular solution will just be y cosine x equal to e times e to the power minus 3 over pi x. Simplify a bit, I will get e to the power 1 minus 3 over pi x. So this is the expression I need. By comparing with the form they want us to show, I can just simply say that a will just be equal to 1 and b equal to minus 3 over pi. All right, so we are done with the part A of the question, and part B of the question say for the graph of the solution found in part A, which is this solution, find the equation of the two vertical asymptotes closest to the y-axis. All right, so for vertical asymptotes, the definition of vertical asymptote means is the value of x that cause the graph to be undefined. So from here, we can see that y is the same as e to the power 1 minus 3 over pi x over cosine x. So we need to find values of x that cause the curve to be undefined, and we can do that by letting the denominator to be 0. Right, so cosine x equal to 0, and we are supposed to solve the values of x. And this x will give me the value of x, this will give me the values that cause the curve to be undefined. So we can recall the general curve of cosine looks like this. And this value here will be pi over 2, and this value here will be minus pi over 2. All right, these are the two values that give me cosine x equal to 0. And basically, these two will just be the values that cause the curve to be undefined. So therefore, we can just straight away say x equal to pi over 2 and x equal to minus pi over 2 are the vertical asymptotes closest to y-axis. Right, so these two values are the answers that I need.